In this video, we'll demonstrate how to scaffold a Web API controller with CRUD endpoints using a simple model class. Also, we'll generate a database with a table and show how to create a service or repository to streamline your controller class. We'll create an ASP.NET Core Web API project. Select the .NET 8 framework and enable Open API support so we get Swagger. But most importantly, make sure to select Use Controllers. While you can scaffold API endpoints without controllers, it's a more common and better design to use controllers. To scaffold our endpoints, we only need a model. We'll add a folder to the project called Models and add a simple model class. Now to scaffold our controller, we right-click on the Controllers folder and select Add New Scaffolded Item. Then select API Controller with Actions using Entity Framework. In the dialog, select the model class you wish to create endpoints for. Since we don't have a data context class, we can add it and maybe change its name to something more concise. We'll be using our SQL Express server, and the controller's name is OK. After a moment, the controller is scaffolded with all the basic CRUD endpoints. We still need our database, but let's first look at what was scaffolded. In the Controllers folder, we find our scaffolded people controller. At the top, we see the default route, and it inherits from controller base. In the constructor, we see it injects the data context, which it uses in the endpoints to perform all the database actions. In a real-world situation, you would rather create and inject a service or repository that handles the database interactions for you. This is better for code maintenance and testing and streamlines your controller a lot. Creating a service for the controller is fairly simple, and we'll demonstrate it in a moment. For now, let's see what these endpoints do. The first get endpoint simply return a list of all the person records. The second get takes an ID value and returns the first person with that ID. The next endpoint is a put endpoint to update an existing person. It takes the ID of the person to update and a person object with the new values to update. It first confirms that the ID values match, then changes the state of that person to modified. Then it tries to save the changes and returns nothing. The post endpoint will add a new person to the database. It takes a person object to insert and then retrieves it again from the database to return the person with its newly generated ID value. Finally, the delete endpoint takes an ID value, retrieves the person from the database, and if it exists, removes it from the database. It also scaffolded a private method to check if a person exists. In the scaffolded data context class, we find the standard constructor with a person DB set. In our program CS file, it added the DB context service that gets the connection string from the app settings file. In the app settings file, it created a connection string, but you may want to edit this to point to your own database server and change the database name to something more meaningful. With that all set up, we can go ahead and create our database. Right-click Connected Services and select Manage Connected Services. Go to your connected database server, and from its menu, select Add Migration. We'll name our first migration Initial. Visual Studio will search your code for a data context file. Once it found it, you can click Finish to generate the migration file. The migration file has an up method to create the person entity in the database, and of course a down method to reverse the migration. With the migration file in place, we can go and update our database. Go to Manage Connected Services again, and from your connected database server, select Update Database from the drop-down menu. Visual Studio will retrieve your data context object and any new migrations you've created. Then, click Finish, and Visual Studio will run the Entity Framework tools to update the database. Let's go to the SQL Server Management Studio to confirm the database and person table were created. Now let's run and test our API. Swagger shows us our people endpoints. The first get should return all the person records. And as expected, there's no data yet. Right, let's go post some new data into the table. We don't need to give it an ID because that will be generated by the database. It adds the person and returns the record with its new ID value. We can add another person. Now let's go back and try the first get endpoint again to see if our added data exists. And the second get endpoint, we can retrieve one person by ID. Next, we'll update a person record. We give it an ID and change some of the person's data. But we get a bad request error. The ID we gave the endpoint does not match the ID in the person object. So we'll correct that and try again. We get a success message. Let's see if changes were applied. Finally, the delete endpoint, we give it the ID of the person to delete. And check again to see if the record was removed. To create our repository, we'll first add a new folder to hold all our repositories, because there might be more repositories in the future. Then we add a class to the folder. We'll call it People Repository. Now we're going to cheat a bit. We'll copy all the code from inside the controller and paste it into our repository class. In the repository class, we start by fixing the constructor method name. Then for each method, we can remove the controller attributes, change the return types, and as is common practice, add the word async to our method name. For the person exists method, you can simply change it to a public method. Next, we add an interface class in the repositories folder and give it the same name but with a leading I. Now we can simply copy the repository's method names into the interface class, but without the public and async. We'll use this interface and inject it into our controller, but first let's fix the methods in the people repository. At the top, we inherit from the people repository interface. The first getPerson method can stay the same. In the second getPerson method, we changed its return type to be a possible null value if it can't find the person. The putPerson method simply changes the state of the person and returns nothing. This is just a quick example of a repository. In a real-world application, you would add proper try-catch blocks and validation code. Moving on to the postPerson method, we simply add the person. And in our delete method, we made it return a bool if it couldn't find the person to delete. The personExists method can stay the same. Of course, to use this repository with dependency injection, we need to add the service to our program CS file. With our repository in place, we can modify our people controller. We no longer inject the data context, but instead use the iPeople repository. This means our controller will no longer have to be concerned with dealing with the data access stuff, but can instead focus on what it's meant to do, handling HTTP requests and responses. In the first getPerson endpoint, we call our service's getPersonAsync method. We do the same in the second getPerson endpoint, but remember, we changed our repository method to return null if it couldn't find the person, so the endpoint can return a proper response. In the putPerson endpoint, we no longer pass an ID to verify the ID in the person record, but that's up to you if you still want to do that. Here we simplified the code and call the repository's putPersonAsync method. And in the catch code, we use the repository's personExists method. In the postPerson endpoint, we add the person, but no longer return the added person record. Again, this is up to you and depends on how your application will use this endpoint. Then the delete endpoint we call the deletePersonAsync method that we changed to return a bool value. If it returns false, the person wasn't found. The private personExists method is no longer needed, so you can remove that. Let's run this and see if it still works. Our first get returns the records in the person table. We'll do a post and add a new person. And check if that was added to the person table. We do a put on that ID and change some values. And check again if the changes were applied. Check if the second get endpoint still works. And finally, delete a person. Thank you for watching our video. For more tutorials on C#, hit subscribe and click the reminder. Give us a like so the video can be visible to more people.